So what if I had required, so when we did that one, we did process expression, we had the numbers. What if I had required that you did the mathematical operations in the appropriate order of operation? Multiplication and division happened before addition and subtraction. That problem would have been a lot harder, right? Because as you wrote it, you just had to do left to right. So Dijkstra is actually the guy who invented Dijkstra's algorithm for minimum spanning trees, which you'll learn about later on. He has this other algorithm called the shunting yard algorithm, and this algorithm uses actually we'll probably do this next semester in the data structures course. He has an algorithm that uses the stack data structure to parse through a string like that, but keeping track of your operators in the right order. But it also takes into consideration parentheses and powers, if you take something to a certain power, where its precedent is, and that kind of stuff. Yeah, so that's their homework assignment for next week. And they also have a 5-page paper, because this wasn't enough. They're grad students. They're supposed to be tortured. What was I talking? Oh, let's see. Where do we leave off? Let's get our keynote open here too. Oh, look at that. Why does it think I modified this so many times? Okay, this is us. Okay, so I think at the end of class last time we actually had it where we could bounce back and forth between our rooms, right? All right, so let's close this. There's our cave crawler. Okay, so now we just have 2 rooms that we can bounce back and forth. So we're in the cave entrance, we type in north. It takes us to room 2 where we see a single exit. It takes us, we can go back south, north, south, north, south, north, south, right? Okay, so now we seem to have a kind of a model for moving between rooms, okay? So question, how would we represent a cave? Right now, we are designing our caves to work in a certain way. So for instance, here in Driver, we're creating a couple of rooms, we're linking those rooms together, right? All right, so you know, when we do that, and this assumes that we don't automatically get a room heading back, right? So that would give us the ability to have one-way doors, that kind of stuff, right? So technically you can go through doors like a trap door and it shuts, and then you're in that room and there's a running wood chipper in that room. Yeah, when I was, I wrote we were talking about MUDs before, these old Dungeons and Dragons things. When I was, I think I was either 11 or 12, I wrote, me and a buddy of mine, we wrote this, a MUD that, you know, was pretty full featured, I guess. You'd run around, you could, you know, kill monsters and stuff like that. But one of the features we put in the game is we had a random wood chipper that would just be in the room with you. And so the thing is, if you ever played a MUD, let's say there's a certain place you always go. Maybe you go to get supplies from this place in town. So you're so used to typing in north, north, northwest, northwest, or something like that to get to that place that you would almost just passively do it. Well, now you might land in a wood chipper. Okay, somewhere there's, you got to be careful. And the thing is once you're in the wood chipper, you know, you're moving with the wood chipper, so it's randomly kind of traversing the world, and you have to try to escape as you're just taking, you know, blunt force trauma, and so you're dying while you're trying to get out of the room, but your exits keep changing. Okay, so yeah, so that's kind of why I messed up. That was a 12-year-old, right? All right, so in any case, we need to have a way of kind of representing our rooms, because in order to build a cave of any size, we're going to have a whole bunch of code like this, right? Okay, so let's go back to our drawing board here. So now we've kind of built this mechanic where we can generate a couple of rooms and we can put exits between those rooms. So now we want to kind of go back to this idea of how do we represent things as strings. So for instance, I want to come up with a textual representation of how we can hold on to this room, this guy right here. All right, and we are going to do this through a modern approach called Json. Have we talked about Json in here yet? At all? A little bit, maybe, sort of, kind of? All right. So we have these things called data representation languages. Data representation. Oh, I've got an extra S in there, don't I? All right, so data representation languages. These guys allow us to store data in an organized and parsable way. All right, so we've historically we did that process expression where we had to parse through that string based on where the plus signs were, minus signs, things like that. Well, now what we're going to do is we're going to look at a modern approach. So this is instead of something made up, instead of us coming up with our own made up format, we're going to use an existing format. But unfortunately for us, we're going to have to write our own parser. All right, because even though Java does have a JSON parser in it, we don't know about it. So we're not allowed to use it. So we're going to have to write our own. Well, before we do that, let's talk about what JSON looks like. All right, so we have a couple of different things. So first, let's look at some examples. Some other examples of data representation languages would be XML and HTML. XML is actually based on HTML, and you can also implement HTML using XML, and that's something called XHTML. All right, so easiest way to talk about these is just through an example. So let's look at the representation of a person. So if I have a person in XML, now all of you have had 150, so I think you've at least seen some HTML in there. So you've seen these languages that kind of look taggy like this tag-based looking thing. Okay, so XML takes that idea of tags, opening, closing tags like we have in HTML, and what it does is it says, you know what, we can apply that to representing all sorts of data, not just representing things that belong in web pages. Okay, so who understands HTML? It's web browsers. Web browsers know how to take this tag-based HTML language and turn it into pretty pictures and text on the screen, right? Okay, well, XML says, well, this whole idea of opening and closing tags for kind of wrapping our data in some sort of structure that we can consistently say, okay, well, I found the opening tag here, I found the closing tag here, let's pull what's in the middle out, and that's my data. Okay, and my data was described by whatever was in the tag. Okay, so XML and HTML they look the same, but XML allows us to invent new tags instead of using the built-in, H1, H2 table tag for HTML. Okay, so HTML is a language based on tags that could be implemented in XML, even though HTML actually came out before XML. XML was inspired by HTML. So if we're representing the idea of a person in XML, we might say person, name, Mike, age, 15, so on and so forth, stuff like that. Okay, so, even though we only have two little pieces of information here, we have a whole bunch of, quote, fluff that's kind of giving it structure so that we can have a program that goes through and says, okay, well, I just added an opening person tag. What does that mean? Well, that means I'm creating a new person. So maybe we create an instance of a person. So this is kind of a textual representation of an object. So we're going to create a new instance of a person. Okay, so now let's keep going. Oh, I just found another opening tag. Tag is of type name. So we're going to go ahead and set the current person's name to the value associated with that, Mike. Then we hit the closing tag. Okay, that's the end of their name. Now we found another opening tag, age. So let's set this current person we're currently building, his age, equal to the value associated with it, which is 15. Hit the closing tag for age. Then we hit the closing tag for person. This object's been built. That make sense? But we're actually walking through this one character at a time. So whenever we hit a less than sign, we say, oh, that's the beginning of a tag. As soon as we don't hit a front slash, we know it's an opening tag, because closing tags start with a less than front slash. That's how we know it's a closing tag as opposed to an opening tag. All right, so punchline here is this is an example of XML. So this is an XML representation of a person. Okay, now let's look at the same thing in JSON. So JSON would be, let's just say, a more modern version of XML. So it accomplishes the identical task, but tries to be less verbose. So we're going to say that XML solves the problem well, but has a whole lot of characters in there for representing a relatively small amount of actual data. Okay? So in JSON, we have a JSON object represented by an opening and closing curly brace. And then we're going to have name, Mike, comma, age, 15, something like that. That's the JSON representation of the same object. Okay? So JSON is our more modern approach. So when we talk about things like APIs, so abstract programming interfaces, what is an API at the end of the day? It is a mechanism for talking to another program. And modernly, it's usually a program somewhere out there on the internet, and sending/receiving data. Now, when we send and receive data between another program, so as an example, let's say we're trying to, most of us on our smartphones, we might have an app for weather, right? All right, so when we open it up, it's pulling that weather information from somewhere. Chances are it's talking to some weather API up in the cloud. It's saying, here is, it's letting it know, here's my current latitude and longitude location, or here's the zip code that's local to me, whatever it is. It's sending some sort of information to allow that API to know where you are. And then it's pulling down from that API the information about the current weather. Okay, and that information is likely, in a modern API, coming down in JSON format. So in the format that looks something like this. We would have been talking about this, let's say 5 or 6 years ago. Was probably a 50-50 shot, but maybe more XML, format. We were talking about this 20 years ago. Now we're getting before the birth of the internet. We probably wouldn't have had remote APIs and stuff like that. So that's where we go to this more generic definition of having two programs talk to each other. Whenever we have two programs that need to communicate information between each other, we have to agree upon a protocol, agree upon how the data is going to be represented, okay? All of us in here have agreed that communication in this classroom is going to happen in English, right? So when I show up, you expect me to speak English. When you ask questions, I expect it to be in English. So we've agreed upon the English protocol, all right? So I know how to interpret English, and you know how to interpret English. So now several of you in here speak another language, right? Okay, I don't. I speak English, bad English, and a little bit of Spanish, almost enough to order a Taco Bell. So the punchline would be, if you asked your question in a different language, I don't have a parser for that language. I don't know how to pull the meaning of your question out of that because I don't speak that language. That makes sense? So whenever we have two parties communicating, two computer programs, two people, whatever it is, we have to agree upon a protocol, a syntax, a language for us to exchange information between each other. And that language needs to be something that we are both compatible with. Make sense? Okay, so same thing's true in our computer worlds. When we have two programs that talk to each other, these guys have to agree upon some sort of format. Now, historically, what would happen is our computer programs would come up with proprietary formats, okay? So me and Emo, we're going to come up with we have a secret code that we use to communicate, right? Remember this? Remember the code? Okay, it's all hand gestures and weird like clucking or see, I just sent him a message. You guys don't even know what I said. Yeah, he gets it. It was a joke. Laugh. All right, so the idea is that historically, when you have two programs that are communicating with each other, and you wrote them both or you worked with somebody else to write them, you may have invented your own little language for having those two guys talk, okay? So now what ends up happening is if I want my program to now talk to somebody else, okay, I have to teach them about my unique proprietary language, and that becomes problematic. So having these data representation languages like JSON or like XML allows us to say, you know what, these are some standards that are commonly used. So if you use one of these standards, you just let the person at the other end know that I'm sending it in XML, I'm sending it in JSON, then they can generically pull the information out. They're going to still have to figure out how to interpret that data. So when we look at this JSON object, all we know is that it's represented in the syntax of JSON. Okay, just like this might be a sentence in English. Okay, I still have to extract the meaning from it. So if I'm expecting you to send me a name and an age, I'm going to look for the name and the age inside of something that's formatted in a very structured way. Okay, just like if I ask you, when is your birthday? Okay, and if you go ahead and give me what you had for breakfast, okay, you've delivered for me stuff in English that I was expecting, but the data that I didn't ask for. Okay, so if you say steak and eggs when I ask you when your birthday was, that's also going to be funny, except it sounds different in our clucking language. All right. So in any case, that's where these data representation languages really came into being, where we had more and more programs communicating with each other, and we had to have some sort of consistent way, a standardized way for them to talk, so that we can bring more programs into the mix and have it be, let's say, easier for us to talk to different things. So now as a application writer, we can write a smartphone app that talks to the Weather Channel's API, and we don't have to know about their proprietary language. We just know that they're going to give us JSON format. And then on their website, they've documented, here's all the bits of information you can expect us to send you. We'll send you these bits of information in JSON format, so extract the parts of that you're interested in. Make sense? All right, so having said that, it might be beneficial for us to go ahead and represent our caves in JSON, right? Give us some good practice for what's coming. Plus, if we ever decide to write our own APIs, like you might in some other future classes, where you are now the source of data, this is going to give us a good starting point. So, as an example, let's build a JSON representation of our current cave. Okay, so at this point, we're having to invent those things. Okay, so we're going to say that this is a JSON cave is what we're looking at here. So all of our caves will be housed inside of a single JSON object. Now JSON actually supports two things. It supports objects and it supports arrays. Okay, XML actually does not support arrays. So in XML, if we had multiple people here, we would just have them back to back like that. In JSON, if we had multiple people, what we would actually do is we would have an object, and inside this object we'd have a variable called people, and people would be equal to I'm just formatting it in a reasonable way, but it doesn't actually have to be. So that's the JSON representation of the same thing. Okay. Difference here is in XML, we have a person, then we just go right into the next person. In JSON, we have a variable called people, And that variable has a value. The value of that variable is actually an array. So possible values that we can have for variables in JSON are either literals, so like Mike 15, stuff like that, or it could be a JSON object, or it can be a JSON array. So this is a JSON array, which is a collection of JSON objects, or it could also be literals. Okay, so in this case, we have a collection of two people. All right, so this is what JSON supports. So if we had something that looked like this, and I asked you to parse it, keep in mind that this part of it isn't actually part of the syntax. The syntax looks like this. All JSON objects start like this, with an opening curly brace. Okay, so we have a JSON object here, and this JSON object contains one variable called person. So think of these like variable value pairs. Here's the variable name, well, it's called people. Here's the variable name, people, and here's the value of that variable. It's an array of what we presume will be people. Okay? And this array holds two elements. This is element at bucket 0. This is element at bucket 1. Element at bucket 0 says what? It says, I have a JSON object. I have a name, Mike. I have an age, 15. Bucket 1, or the second element, says I'm also a JSON object. I have a name, Dave, and age, 12. So this guy in Java would create a variable named people that is an array containing two person objects, where the first person object has a name, Mike, and an age 15, and the second person object would have a name, Dave, and an age 12. Make sense? That's why JSON's become popular, because we can think about JSON in terms of our modern programming languages as well as in terms of objects. Okay, things that we've already been working with. Let's see, what does JSON stand for? I think it's JavaScript Object Notation. I think so. That's what JSON stands for. So it's actually based on the syntax of JavaScript, which is based on the syntax of C. So that's why these curly braces and the square bracket stuff for arrays look at least mildly familiar to us, right? Shouldn't look like complete foreign language. All right. So given that, let's go ahead and give ourselves we're going to make a pass at a representation of what we might use to represent this cave. All right, we've programmatically written our cave here, but we can certainly extrapolate that if we had a cave with very many rooms in it, this would start getting scary pretty quick, right? But if we can take this exact same thing, represented in JSON, and then write a parser that automatically does this for us, life would be easier. Because then essentially we have a cave player. We have something we can feed any JSON file to that is in cave format, our JSON cave syntax that we're using, and it would just build that cave for us. That make sense? That would be nice, okay, except we're going to have to do some work in order to make that happen. And by we, I mean you. All right, so let's go back into this. So let's come up with what is a cave? Okay, a cave is a collection of rooms, correct? And these rooms are linked to each other. Now, does every cave have an entrance? Every cave does have an entrance, right? So, at least in our world. In our world, a cave is useless if we don't have a starting room, correct? So every one of our caves has a starting room. And then that room kind of branches out into other rooms. Okay? So, right now, let's just go ahead and let's create our starting room. So inside of our cave, we're going to have a variable called start room. And start room is going to be equal to a room object, correct? And what's a room object? Well, in our case right here, our cave entrance is actually our start room. Okay, and we've decided that rooms have a name, the name of the room, and a room also has a collection of exits. Probably an array of exits, right? Okay. Now, when you have an array of exits, where does it go? It goes to another room. Make sense? Okay, so this is where we're going to have to be careful with our representation of our caves. So let's go ahead and individually build our two rooms. Forget about exits for a second. Okay, so we have a room called the cave entrance, and we have a room called room 2. Keep it relatively simple. All right, so we have start room, and this guy is a JSON object. And I'm just going to put it all in one line if you'll. Well, I don't really want to do that. I think we have to. We're going to do it anyways. All right, so this guy is going to be a start room is going to be a room object, and this room is going to have a name, and the name is, what do we call it? The cave entrance? The cave entrance. Okay, that's the end of that value. So start room has a value, and the value is an object. So this is how we represent JSON objects, just inside of curly braces, with a comma delimited list of the fields. Okay, so realistically, we're calling them objects, but based on what we've learned in this class, what is this guy sort of like? So this is a JSON object, but a JSON object is like what from the C programming language? A struct. It's like a struct. Did you say struct or string? Say string? Well, we'll pretend like he was right. Struct. Okay, so this guy's like a struct. A struct was a collection of fields, a collection of variable value names, right? Variable value pairs, but it didn't have functions in there, which is okay because JSON is only textual. We don't have the ability to program abilities into this. Okay, we're merely holding information. We're going to have our Java program, in our case, take this JSON, build objects out of it, and those objects are going to be able to do stuff. We don't get to represent what they can do in JSON. JSON's just a suitcase for carrying around information. Okay? So what we're calling here, what in JSON lingo is a JSON object, is actually, okay, this guy is actually a representation of a struct. This is an object that contains exactly one variable value pair, and in this case, the variable name is name. The value of that is the string cave entrance. Okay? This whole thing, though, is the value associated with this variable name, start room. So we're going to say every cave has a start room. We can expect it. All right. Then let's go ahead and let's create the other rooms. Okay, so I'm going to just put another room in here. So we're going to call this guy a, well, for right now, let's just, we're going to call this rooms. These are the other rooms in our cave. Okay, so other rooms in our cave is going to be an array of rooms. So right now we only have one additional room, and that one additional room is actually going to be a room whose name is, what do we call it, room 2? Okay, and that's it inside of that guy. All right, so we have, and we actually need to put a comma here. So a JSON object is actually a comma delimited list of name value pairs. So here's a name, here's a value. Okay, followed by a comma. Here's a name, here's a value. Here's another JSON object. Here's a name, here's a value. Okay, so this guy, the names are always strings. The values can either be JSON objects, values can be strings, or the values can be JSON objects, or values can be JSON arrays. That guy. Okay, so 3 different types of values we're allowed to have in JSON. It just so happens we have the ability to create objects, we have the ability to create arrays, and we certainly have the ability to create strings. So we already know everything that we need to know about representing what's in text here inside of Java stuff. Okay? But now the hard part for us is going to be how do we go from this format into this format, and vice versa. Okay? So here's, we're going to have a collection of rooms. Inside this collection of rooms, we have exactly one. Okay, inside this collection of rooms, we have exactly one room in there right now. Okay? So Now we have a cave, and inside this cave, we've given a start room like this, and we have our rooms collection having all the other rooms. We have no way of linking these guys together, correct? Okay, so now having said that, how do we actually link these rooms together? How do we uniquely identify our rooms? So if we go back to this picture here, let's see, was it this guy? Right now we just have 2 rooms, and they're just sitting out here in the middle of nowhere. But let's go ahead and surround this guy with 200 of his buddies. So we have 200 rooms. Visually, this is going to be a collection of boxes with lines all over the place, right? Is it going to be beneficial to us to be able to uniquely identify a room? And can we guarantee that a room is uniquely identifiable by its name? Could we potentially have 2 rooms named the cave entrance? Or could we potentially have 2 rooms named room 2? Okay. Or could we potentially have 2 rooms named upstairs? Certainly we could. Those aren't unique names. So we probably need to have some sort of unique identifier to identify each of our rooms. All right, so now we're going to go back into our JSON. We're going to add a little bit more information to what's a room. So now a room is going to have a name. Actually, let's start it with the ID. It doesn't matter what order they come in because, you know, when you read it name, you'll get its value. When you read it ID, you'll get its value. So we'll say this guy has an ID of 0 and the name of that. Then this guy is going to have an ID of 1 and a name of that. Make sense? So we've expanded the definition of what our rooms are now. Instead of being 1 piece of information, just a name, now it's 2 pieces of information, a name and a unique identifier. All right, so now what I'm going to do is I'm going to steal this room here. Let's do it like this. We're going to call this start room ID. We're going to set the ID equal to 0. So now we have a collection of rooms that exist in our cave. So this is a variable called rooms that's equal to an array of JSON objects. And in this case, each of these objects is a room. This first room has an ID of 0 and a name of the cave entrance. The second room has an ID of 1 and a name of room 2. Okay? And then we close off the array. So this guy right here is the value of this variable called rooms. These are all the rooms that exist in the cave. Make sense? We have one variable here called start room ID. This just holds the identification, the identifier of which of these rooms is actually the start room. Make sense? Okay, so now we represent our data there. Now, we have exits. So just like our cave is made up of a whole bunch of rooms, our cave also has a whole bunch of exits that inhabit it, right? All right, so what does an exit look like? So an exit is going to be a collection, just like rooms is. But an exit object, is an exit also going to have an ID? We have to uniquely identify our exits, right? So an exit's going to have an ID. So let's just say this is exit ID 0. So we can have exits with an ID of 0 and a room with an ID of 0, but you wouldn't want to have 2 rooms both with ID 0. All right, so using integers as our baseline for our identifiers, what's the maximum number of unique rooms we could have in our cave? Given how big, what's the maximum size an integer can hold? 7, 9, 2 billion, or cat? All right. Correct answer is, of course, cat. All right, that's a code name for 2 billion that we use in our weird language. All right, so 2 billion, remember integers, plus or minus 2 billion? It's the range of values. So if we always start off at 0, we could hold, if we started off at negative 2 billion, we could hold 4 billion unique rooms, but I don't think we're going to get that big of worlds in here, right, that we're going to start hitting 2 billion rooms. So we're going to say we're good starting at an ID of 0 with a maximum ID of 2 billion. Just make sure you don't create more than 2 billion rooms in your caves, okay? And we'll be cool, right? We'll worry about this once we start working with us trying to resell this to Blizzard Entertainment or Bungie or something like that. It would actually be really funny for us to like build up like this whole document around this thing and then literally send it to them as like a real proposal. It's like, you can only have 2 billion rooms. So, it's a limitation, but, All right. So in any case, we're going to have an array of all the rooms that exist in our cave. We're also going to have an array of all the exits. An exit's going to have an ID, and it's going to have, did we call it a name? Let's just make sure we're somewhat consistent. Okay, it has a name. Now, it also has a destination in there for our room, but we're not going to put it in our JSON, and you're going to see why here in a second. We're not going to put it here. We're going to associate exits with, we're going to associate exits with rooms, but we're not going to necessarily associate exits with the rooms they live in. We will ultimately put the destination in there, but right this second, we won't see it. Let's just make the connection. So every room's going to have an ID. Every room's going to have a name. Okay, and the name is, in our world, is north, south, east, west, right? Okay, so let's just say this first room, we're just kind of building our cave here. Our first exit is north. Okay, so name is north. All right, let's just end with that for right now. Okay, and then we're going to have another exit. ID is 1. Name is south. Okay, just like that. So now we have a collection of our exits that exist in our cave. Okay, now what are we going to do? Every single one of our rooms is going to have a collection of exits. And we see that represented here in our rooms, right? A room has an array of exits. And we've said that our room can hold up to 4 exits. Realistically, our JSON can support more than that, but we'll keep it consistent. So now we're going to add another field to our room. So we're going to have exits. And what kind of value will exits be? An array, right? So exits is going to be an array of rooms. Exits is going to be an array of rooms. Or, I'm sorry, an array of exits. Exits will be an array of exits. And what is an exit? An exit is an ID. All right, so this guy is going to be an array of IDs that correspond to exits that are down here. So the cave entrance has within it exit 0. Room 2 has within it exit 1. Make sense? We could have multiple exits in here, so we can have 0, 2 if we add a third exit here, right? But right now, each of these rooms have exactly 1 exit in it to match. So now, we're keeping track of the unique identifiers of exits here, and then we're keeping track of our unique exits down here. So now every exit leads somewhere, like we said before, so it's going to have a destination. So now we can go ahead and put it back in. So we saw how we match it up on this side. So instead of having our entire exit objects stored here, we're going to have a collection of exits, okay, as we're writing it right now. So now an exit is going to have a destination, and that destination is going to be an ID, right? So why don't we call these exit IDs? So that's what it is. It's a collection of identifiers for our exits. And why don't we call this the destination ID? That is the single ID of the room this guy goes to. So north goes to ID 1, south goes to ID 0. That make sense? All right, so now we have rooms and we have exits. Okay, so here's one way we could have represented it. So I'm going to do something else here. Actually, let's just copy this entire thing. Now what I'm going to do is I'm going to actually take our exits. Let's do that. And we'll do this. And then we'll get rid of exits down there. Here's an alternative way we could have represented our rooms, where we have a collection of rooms, so we're definitely keeping track of where the beginning room is by its ID. Then we have a collection of rooms, each having a unique ID. Every room then has a collection of exits, but maybe instead of calling them exit IDs, we're going to call them exits again. And that is actually an array of JSON objects, where each object is a representation of an exit. So this exit has an ID of 0, a name north, and it has the destination ID, that is where it goes. Well, this guy goes to destination ID 1, which is actually this room right here. So it's a room we haven't read in yet. Okay? Now, either one of these is viable. We have to ask ourselves a couple of questions, though. First thing is, can one exit lead to more than one room? I guess to ask the question a different way, are exits reusable? Because of the way we implemented our exit, where the exit has a destination ID associated with it, which is a unique identifier associated with a room that it leads to, every single exit is unique within our cave world, right? Every single one's unique. So an individual exit can only exist one time. So if we have 30 doors in our cave, or 30 exits in our cave, we're going to have 30 separate exit objects in here. So is it a problem to associate our exits with an individual room in which they live? Not a problem, right? That's how we've written it in code. But now we have to think about how we're going to be parsing this. As we walk through this, so both of these guys equivalently hold the same information. So if I gave you this JSON string, or I gave you this JSON string, any one of us, after a little bit of practice of reading some of the JSON, could kind of extrapolate this picture from it. Right? And you can come up with that picture from that JSON. It's like, okay, we got a couple of rooms. This guy was ID 0. This guy was ID 1. Here's an exit. This exit had a ID 0. This exit had ID 1. So you can ultimately draw out that picture, correct, given that JSON, either one of those JSONs. As a human being, we can make a first pass through this and kind of create all our objects, then make a second pass and go and link them up. Okay? Similarly, maybe when we take an exit, right now, if we look at our code for an exit actually goes to an actual room, goes to a real room, a pointer to the room, as opposed to having the ID of a room that it leads to that we might have to go look up somewhere. Okay? So we might have to change our implementation a little bit. On one hand, if we need to know about the room an exit goes to before the exit exists, then I need to have these guys stored separately. If instead I decide that I want to resolve my rooms or resolve my exits based on their ID when I need them, then instead what I'm going to do is I'm actually going to store all of my exits in some array somewhere, all of my rooms in some array somewhere. My rooms are going to have exit IDs associated with them, but they're not going to actually be needed until somebody takes that exit. So I've kind of filled my world up with all the information I need to begin with. I have a collection of exits with IDs, I have a collection of rooms with IDs, and I know where the cave starts. And if I have that piece of information, then what can I do? I can say, okay, well, I'm going to go through and I'm going to say, well, they said they wanted to take the room to the north, the exit to the north. The exit to the north says it goes to room ID 1. Well, where the heck is room ID 1? Well, let's go look. We're going to go through our list of rooms, find room ID 1. Here's the actual room. So we're going to search through that array of rooms, find the room with ID 1, and we're going to take them there. That make sense? All right, so we have to decide how we're going to handle it. Now, which of these two representations do we like better? Do we like the one that has all of our rooms in one collection, all of our exits in another collection, and we just hold the IDs? Or do we like the one that embeds our exits inside of our rooms? How many of you like this one? We have to have 100% voter turnout or I'm going to make the assignment a lot harder. Okay, how many of you like this representation? Where we have two separate arrays, one that has our collection of our rooms, another array that has our collection of our exits, and then these guys will be mapped later on based on the IDs. 0 people, okay. Who likes this one then? Everybody else. Interesting. Why? What do you like better about this one? Do you think this is harder to read? Now, keep in mind that our parser is going to be the guy who actually reads it, so we don't necessarily have to be able to read this. Okay. It's really interesting, because I would have picked this one in a heartbeat. To have two global collections of all our exits and all of our rooms, and go down here and be able to like look, okay, here's an exit, here's its name. It goes to room 1, so we know it's going to go here. Where did it come from? Well, I just need to find its ID up here in one of these rooms, and that's right here. Okay, so I have to look up 2 pieces of information there. When I see this guy's room says, I have exit with ID 0, I have to go find exit with ID 0 down here, and then see where he leads. As opposed to, so I have to do 2 separate lookups, because this guy leads to room ID 1, which is actually this guy. So I have to resolve the 0 to this exit, and I have to resolve the 1 to this room. In this model, I have to resolve the destination here to this room, but does an exit even need to have an ID in this model? Do we need to be able to uniquely identify exits in this model if they actually already belong to rooms? So I actually do that. So a room has a collection of exit objects, where an exit object has a name and a destination ID. This destination ID is the room it goes to. So I would have to resolve this room ID to the room it leads to later on, but I wouldn't have to look up exits and rooms. All right, so we picked this one, we'll go with it. All right, so this is our representation, but in order to even start, we need to be able to read in something in JSON format. Okay, so we're going to go ahead and give ourselves a starting point for this. So we're going to take in a string that looks like this. Okay, a string that looks like this. And we want to be able to actually read this in from a file. Okay, so we're going to do some file I/O stuff today. So I'm going to go ahead and copy this so we can paste it into a file. So I'm going to go into our code, and this guy actually gets a little bit funky when we do files. So I'm going to the issue is that the way that Eclipse sets up their projects is they have two folders, a source folder and a bin folder. The source folder is where our code lives. The bin folder is actually where the programs are being run. So if we want to give it a relative path to our file, we actually have to store our file inside the bin folder because that is the local directory that our code is being run from. All right. If we store it inside of our source folder, when we run our application, it runs out of the bin folder. It won't know about that file that's in the source folder. All right, so I'll kind of show this to you. So let me do this. And what's worse, I guess, is we don't actually have access to the bin folder here inside of Eclipse. So I'm going to come out here to our terminal. And let's see where we are here. See, we have two folders, source and bin. So source is where our Java files live, but bin is actually where the compiled version of these guys live. So when we run our program, when we hit the play button, we're actually running inside of this folder. So if we have a local text file we want to be able to read from, it has to be in that folder, not in the source folder. A little bit inconvenient. Otherwise, we have to give it the full path of where that guy lives, which, let's see, we might be able to actually pull off here. Let me try something. So I'm going to create a new file, and we're going to call this cave JSON. It's our file name, and we'll go ahead and paste our stuff in there. Okay, so now we have that. Next, we're going to go ahead and we're going to just try to read in from this file inside of our driver. Okay. So I'm going to go ahead and just comment out all this stuff for right now, because the hope is later on we're able to not have to write most of this. We just have to create our player and throw them into the cave entrance, right? All right. So let's go ahead and try to read in from this file. So let's go to the documentation. Figure that would take me to where I wanted it to go. Okay, so we're going to be looking inside of Java.io. So it's a package up here. We've used stuff from java.util, but now we're going to use stuff from java.io. And one of the things is going to be a file reader. And we have a file input stream. So here's a file reader. Let's look at the constructor for that. So the file reader constructor requires that we give it a file name. Okay, well, there's actually a couple of different ways to build it. We can build a file reader given a file. We can give a file reader given a file descriptor, which is a kind of a pointer to a file. Or we can build a file reader using a file name. Now, a file reader is of type input stream reader. Okay? And another input stream reader that we know about is system.in. Okay, well, that's actually an input stream. But we'll look at this here. Okay, so this guy is an input stream reader. Now we need to have the ability to read from the that file. So we have a couple of ways of doing this. One is we can use something called the buffered reader. Buffered readers are built using some sort of reader. So a input stream reader is a reader, which, well, a file reader is an input stream reader, which is a reader. So that would be allowed. Similarly, we can go into java.util. Have we used scanner in here yet? Okay. So we can go into java.util, and we can see the scanner class. And the scanner class has some constructors. Notice the scanner can read in from a file. It can read in from an input stream. It can read in from a path. It can read in from a source, but the source is actually a specified string, so you can actually use a scanner to read in from there. So scanner knows how to read in from a file. Well, let's look at file. How do I build a file? One of the ways I can build a file is with its name. So here is the path name to the file. So I can actually use a scanner in the way we've already been using scanner to read in from a file given a file object built with the path name to a file. Okay, so let's see what that looks like. So I'm going to go ahead and say scanner input is equal to a new scanner. All right, and this guy is going to be built using a new file. And the path to this file we might assume is cave JSON, like that. Okay, so it wants us to import java.utilscanner and then java.io file. Okay, and it's saying that this guy potentially can throw an exception, file not found exception. All right, so I'm going to actually just go ahead and just for the sake of argument right now, we're going to say throws exception up here. So we'll just pass the buck. We haven't talked about exception stuff very much, right? So let's not worry about it right now. For right now, just do that. Okay, something bad can happen here, and when something bad happens, instead of dealing with it locally, we're just going to go ahead and send it to the Java virtual machine, and he'll print out a nice red error message for us that makes our program crash. And everybody will be happy for right now. All right, so we're going to go ahead and try to read in this file called cave JSON, which is this file we wrote right down here. Okay, so let's just start with that. Okay, right off the bat, we get a file not found exception. It does not know about that cave JSON file. Okay, because like I said, our program, when we hit play, is actually running out of the bin directory, not the source directory. Okay, so what does that mean we need to do? Well, we could try a couple things here. I'm not sure this is going to work, but I'm going to say bounce up a directory, then go into the source directory, then go to cave JSON. Let's see if that guy will find it. Doesn't like it. Okay. So I was hoping that that would allow us to, because dot goes up a directory, /source will go into the next thing, and then cave JSON will go into the next thing. So it seems like the only way we can make this work, doing it this way, is like this. See, I think I'm gonna even have to rewrite parts of this. So I copied literally the full path of where that file lives. Like this. Now the problem is when you guys download this file onto your computer, you're not gonna have the same directory structure, right? Okay. Oh, it still can, oh, did I not put the file on there? I did put the file on there. /cave JSON, save that. All right, now it finds the file. Okay, perfectly happy with it now because I told it every place to look to find that file. Now let me try something here real quick. Let's get rid of that. I'm going to drag this guy out here and see if he gives me, oh, it wouldn't give me the path. Oh, thank you. I don't think that's going to do anything for me. Let's try that. Oh, very nice. No, still can't find it. All right, so the cleanest way for us to make this work so that when you download the file and it still works, is you'll have to create your own JSON file. I'll go ahead and leave it in there so it'll get put in with the GitHub. Otherwise, we have to write it outside of Eclipse in order for it to just work, so it's all in the same directory. So I'm going to name the file cave.json. I'll provide it for you here. What we actually have to do is out here, I need to copy cave.json into bin. So we see it here and understand that any changes we make here will not change what's in bin. All right, what's in bin is a copy of this file, not the identical file. But the side effect for us is this line now works because it's not finding this copy of it, it's finding the one I just put in the bin directory. Row. Cave.json is in the bin directory. Oh, interesting. Well, it's definitely not required if we run this locally. So if I come out here, so I'm in that bin directory right now. If I say Java driver, it can find it. I mean, I'm sitting in the directory with it, right? So it can find it from there. So Eclipse is running this. I thought Eclipse is running out of here. Runtime directory Eclipse. Default Eclipse. Oh, that's the working directory. Read from file with Eclipse. Let's see what this guy gives us. Okay, that's actually going to be okay. It gives us the full directory. So that means that I can say, give me this guy concatenated with /source/ this guy. It finds the file. So that's actually finding this one. So we're going to ask the system to get us the current user directory, which actually takes us into the source directory of our project, so not inside bin or inside source. So then I say, go into the source directory and you'll find the cave.json file. So this should work for everybody, which means then that I no longer need the cave.json file here. Okay, so now that we have our input, we should be able to read from that file. All right, so let's just go ahead and we're going to say while input dot has next line. So as long as there's more stuff to read, let's just do system.out.println input dot next line. So that'll read the next line. So this should prove that we're reading it in by spinning it out to the screen. Okay, so it's reading one line at a time, blah, blah, blah. So what I'm going to do here is we're going to say string, the JSON starts off as the empty string. Rather than printing it out to the screen here, we're going to say the JSON is equal to the JSON concatenated with whatever the next line is. Then we'll go ahead and say system.out.println the JSON. So rather than print it all out all at once, we're going to go ahead and read it into a local string. That is the string that we intend to parse. Okay? And then we're going to print out that string. So there's our string. Okay? Doesn't print as pretty, but we don't need all those carriage returns and stuff like that in order for our parser to work. Because our parser is going to walk through this not with human eyes, but one character at a time. Correct? All right, so now we're going to create a class in here. It's going to kind of get us started for our homework. We're going to call this guy Cave Parser. Okay, and Cave Parser is going to have a private string called the JSON, and we'll have a public Cave Parser that's going to take in a string JSON as a parameter. And we'll say this dot the JSON is equal to JSON. Okay. Then we're going to have a public, let's say public, let me create a couple of other objects for us here. So you have the pieces that you need. So we're going to create a JSON object. And we're going to create a JSON array. You don't have to use these, but I would encourage you to do it in terms of these. So we'll have a public JSON object parse method, and this guy will walk through our JSON string and create a JSON object, which is a collection of name value pairs where values can be JSON objects, JSON arrays, or literals like 5 or 7, stuff like that. Okay, so in the end, you're going to return a single JSON object. You're going to walk through this guy one character at a time. As soon as you hit as a hint here, when you hit an opening curly brace, that's a new JSON object. So right off the bat, we're going to create a brand new JSON object. Then we're going to start filling it in with IDs, with names, with well, we'll have an ID, we'll have a name, and then we're going to have a JSON array of exits. Okay, so you can assume for our JSON objects that our JSON objects come in two forms. Okay, it can come in the form of a thing that has an ID and a name and a room, or it can come in the form of something that has a name and a destination. Now, the problem is we don't know about inheritance yet. Okay, we're going to fix it when you come back, but what we need to do for this one is instead of an object having a collection of these things, what we're going to do is we're going to say our objects just hold those guys as a string. So you'll concatenate those together. So what we'll do here is you're going to have an object that holds those three guys. Actually, we'll have an array of strings. I think that'll work out the best. I'll give you an example in the homework to make it easy for how you should parse this, just so you don't have to do something too crazy. But we're going to have it store generically just the pieces of information. So we're only going to halfway parse this for next class. So we're going to start the ball rolling, and we're going to start piecing in these things and just give ourselves all the objects we need. So I'll show you what this guy starts with and what your end solution should look like. Okay? So I'll put that in there here in about 10 minutes or so. I'll get it up there. And I'll upload this code as well to GitHub for your starting point. All right, I'll see everybody on Tuesday.